2011 Canadian Open Mathematics Challenge, Part A. If r is a number such that r squared minus 6r plus 5 is 0, what is the value of r minus 3 squared? Let's just do this the old-fashioned way, which is figuring out what r is, and then we can plug it into here. So this factors very nicely, I believe, r, 5, 1, negative, negative. So that means r is equal to 5 or 1. Okay, so now let's go back and plug it into there. If r is 5, then we would have 5 minus 3 squared, and that looks like 2 squared, which is 4. Okay, if r is 1, then we would have 1 minus 3 squared, which is negative 2 squared, which is also 4. So regardless of r being 5 or 1, the answer to the value of r minus 3 squared is 4. Carmen selects 4 different numbers from the set 1, 2, 3, 4, 5, 6, 7, whose sum is 11. If L is the largest of these 4 numbers, what is the value of L? We just have to fiddle around with this. Let's see. I have to choose 4 different. The keyword there is different. So let's see what happens. If I choose the first 4, 1, 2, 3, 4, 1 plus 2 plus 3 plus 4, which is the sum, which is what they want us to figure out, that is 10. Okay, well, that's not 11, so obviously that can't be the 4 that I choose. But I can choose 1 plus 2 plus 3 and 5. That will be 11. And therefore, in this particular case, the largest is 5, so L is equal to 5. Now, we have to figure out if that's the only scenario. And I think so. I think if you play around with these numbers, this is the only possible way that you can have 4 different numbers from that set whose sum is 11. And therefore, L will be 5. The faces of a cube contain the number 1, 2, 3, 4, 5, 6, such that the sum of the numbers on each pair of opposite faces is 7. For each of the cube's 8 corners, we multiply the 3 numbers on the faces incident to that corner and write down its value. In the diagram, the value of the indicated corner is 1 times 2 times 3, which is 6. What is the sum of the 8 values assigned to the cube's corners? Okay, so we don't need to create a work of art here, just something basic that we can use to sort of talk about this. So let me just draw some dashed lines here. Okay. So let's fill in the numbers first of all, and we'll just do it the way they did it. So we have 1 here at the front, and then we have 2 on the top and 3 on the right. Now I've got to put in the other ones. Remember, the opposite faces have to add up to 7. So that means this is 4. Let me use a different color here. This on the left will be 4, on the bottom will be a 5, and on the back will be a 6. Okay. And then what I need to do now is I need to label the corners. So I'll label the corners A, B, and so on, right? So we've got A, B, C, D, and then on the bottom, A, B, C, D, and then E, F, G, H. So E, F, G, H. Okay, now for each of these, I've got to figure out what is their value. So write down the corners A, B, C, D, E, F, G, H, and then for each, I've got to figure out what is the value. So I'll just do A, B, and then you guys can do the rest because it's pretty self-explanatory. For A, the numbers that are incident to that corner are 4, 6, and 2, right? So that means A, the value is 2 times 4 times 6, which is 48. Okay, let's do one more. B, the numbers incident to that corner are, let's see here, 2, 6, and 3. So that means B is equal to 2 times 3 times 6. So that is 36. And then the other ones, You guys can do them. I'll just write them out. 1 times 2 times 3, which is 6. D is 1 times 4 times 2, which is 8. E is 4 times 5 times 6, which is 120. F is 3 times 5 times 6, which is 90. G is 5 times 1 times 3, which is 15. And finally, H is 5 times 1 times 4, which is 20. And then we just have to add up these guys, all of these. And when you do, you get 343. So that is what they want in this question. In the figure, AQPB and ASRC, they are squares. And AQS is an equilateral triangle. If AQS is 4 and BC is x, what is the value of x? Okay, let's blow this up a little bit. I think that should be enough. Okay, so these are squares, so all those sides are the same, right? And then they tell me that this is an equilateral triangle, so all those sides are the same. So there you go. So that means all of these are 4s. This is 4, this is 4, and so on. I don't know if that helps in any way, but those are all 4s. Okay, so now we have to figure something out here in terms of angles. So this angle right here is 90 degrees because it's part of a square. And therefore, this angle is also 90 degrees. This is 60 because that's part of an equilateral triangle. So this angle, which I will call I'll call it theta. It doesn't really matter what you call it. But before I label it, I actually want to draw a line that goes down perpendicular from that point to BC. And some of you already know why, but it's because I'm going to eventually use just half of that angle. So this whole angle I will call theta, right? So this whole angle in here, this whole angle will be theta. So all the angles that go around are equal to 360. So in our case, it's 60 plus the one right angle plus another right angle plus the theta. And that is equal to 360. So therefore, theta would be 300 minus 180, 120. So this triangle, because it's isosceles, if you drew a line like I did, it would chop that angle into half. So what I'm going to do is just draw that triangle over here on the side to avoid making that diagram messy. This triangle right here, that one. And let's label it. This is a right angle. This is now theta divided by 2, right? Which is 60. And then therefore this angle must be 30. And this is going to be x over 2 because this is all x. And the property in an isosceles triangle is that if you draw a perpendicular, it chops the bottom into 2 equal segments. So this is x over 2 and this is x over 2. Okay, and then we know that this is 4. Great. We have everything we need. So for the millionth time on a math contest, we have a 30, 60, 90 triangle. And the ratio of the sides are 1, 2, and root 3. So therefore, that means that root 3 over 2, that ratio is equivalent of x over 2 over 4. And that's basically how you will solve for x. So that means that 4 root 3 over 2 is equal to x over 2. That means x is equal to 4 root 3. And that is what they wanted, the value of x.